Hi, I'm Ariel,
I'm Abby.
and in this presentation, we present MediScale, a weight-based medication management system. This application utilizes a hardware load cell sensing component and a web interface to monitor medication bottle weight for continuous passive dose detection. This application is designed to address the problem of medication non-adherence, which affects approximately 50% of patients with chronic illnesses. Both over and underdosing on medication can contribute to negative health outcomes and higher healthcare costs, putting burden on both the patient and the healthcare system. Many different types of medication trackers are currently available, but primarily rely on patient memory, such as reacting in response to a mobile reminder or logging doses in an app, or monitoring container access, such as smart pill boxes that open at predefined times to allow users to take a number of medications. However, these solutions fail to detect the proper quantity of medication was actually removed. Our research goal is to develop a low-cost system that uses continuous monitoring of the medication bottle to automatically detect medication removal events.
The methods we used to detect medication changes was using the difference between bottle weights based on events from the scale. So a bottle was placed on the scale and the hardware measured how much the bottle weighed. The bottle was then removed and any pills were removed, and when the bottle was placed back on the scale, the device then detected that the bottle weight had changed and used that difference to determine pill weight. It estimated the individual pill weight based on that difference, and it also was able to understand when multiple pills were removed based on a calibration factor. The scale continuously monitors the bottle weight for any events, such as picking the bottle up, returning it without any changes to the pills, and putting on a cap or other unexpected weight change. It detects and classifies each of these events based on the difference between the bottle being lifted and the bottle being placed back down. The architecture we used was a 1 kilogram load cell. This was placed in a custom 3D printed 2-plate configuration. The load cell was then fed to an ADC, which was the HX711. That one fed into the Arduino Mega, which is our breakout board. This Mega Arduino was able to capture the events in the firmware and send it to Python middleware. The Python middleware then did some calibration, including detecting noise level, and sent the events to a REST API. From there, the Svelte web interface was able to interface with the API in order to understand events, display events to users, and overall just make the scale usable by a patient who was tracking their medication. The outcome of this was an interface that allowed users to track medication based on weight changing events. Some of our hardware features include the 3D printed mounting structure, and one note I want to make is that the total cost of this prototype was around $15, which fulfills our research goal of developing a low-cost system. Some of our software features were the debounce and the difference detection in the firmware, as well as a noise floor calculation and some calibration options. And we also made our UX mobile and web friendly. Some of the user features of the software include the dose detection, and on dose detection, the user can save the event so they can record that the medication was taken. The calendar view shows at a glance when the user has missed a dose, when they have taken a dose, and if a dose is pending for that current day. There is also a settings screen that allows the user to recalibrate their medication, to change their medication name or dosage, and even reset the app fully in the case of a bad state.
The strengths of the system are it's able to passively monitor the weight of the medication without relying on the user to manually log when a medication event happens. It's also able to make direct measurements of medication. When the quantity changes, it's able to differentiate between one pill being removed and two, or many different pill sizes, and is a low-cost hardware platform. As we said, the total cost of the prototype was around $15. Limitations of the system are it does require calibration per medication as we have the prototype set up, and it also cannot distinguish medications with identical weights. The prototype was evaluated in controlled conditions, so a next step would be to evaluate it for a real-life use.
We conducted 2 experiments on the device. First, we evaluated the software performance, and it did perform significantly well with pill sizes down to about 0.2 grams. We also evaluated it with pill counts of 1 to 5 pills, and it was able to consistently detect the quantity of pills across 4 different pill types. We did experiment with a pill type below the threshold of 0.2 grams, and it was able to consistently detect pills removed, but was not able to detect the quantity removed accurately. This could be a point of improvement where we can calibrate based on multiple pills removed for smaller pill sizes, in which case the calibration factor would be more accurate to the actual pill size and pill weight. The hardware performance was also relatively good. As the size of the pill or the amount that the scale was weighing decreased, we did see a pretty big fluctuation in percent error as expected and as recorded in the data sheet for the sensor. As the amount removed from the scale increased, you can see there's a pretty big line right there after 0.03 grams, where the error percent was very low. In fact, once you get to about 0.3 grams, there's almost no error in the scale. This is with some smoothing options, including the calibration and the debounce to ensure that the scale functions well.
Overall, the MediScale application we developed demonstrates the use of a low-cost sensing system to effectively monitor medication usage by weight. This provides a foundation for scalable medication adherence support. Future work may focus on improving detection accuracy, supporting multiple medications simultaneously, and evaluating with user testing in real-world home environments. Thanks for listening.